A rational function is a function of the form r of x, which is just p of x divided by q of x, where p and q are polynomial functions and q is not the zero polynomial. The domain consists of all real numbers except for those where the denominator q is 0. So just what would give us 0 in the denominator? We got to make sure to avoid that. So we're going to find the domain of each rational function. So we have the rational function r of x equals x plus 2 over x squared minus 5x minus 14. And the easiest way to understand how to find the domain of a rational function is ignore the top. You don't care about it. You're only focused on the bottom. So we just take the bottom and we set it equal to 0 to find out what would give us 0. So we can factor this quadratic, and this will just factor out as x minus 7 and x plus 2. And we set each one of these equal to 0. So x minus 7 equals 0, x plus 2 equals 0, and then solve, and we're going to x equals 7 and x equals negative 2. Now this is what will cause division by 0 in this fraction. So we can't have x being 7 and negative 2. So what is that as a domain? Well, remember, domain runs from negative infinity to positive infinity. So with our domain here, we're going to start at negative infinity, and we're going to go up to the first number that gives us a problem, which is negative 2. And we stop there, jump to the immediate other side of negative 2, and keep on going until we get to our next problem, which is 7. Then stop there, jump to the other side of 7, and then just keep on going until we get to infinity. And so this, in interval notation, is the domain of our r of x function. Next, we have the rational function f of x equaling x plus 9 over 2x squared minus 9x plus 10. Again, like I said before, we're trying to find the domain. We don't care about the numerator, just focus on the denominator. So we take the denominator as it is and set it equal to 0. And from here we're going to factor, and when we factor this, it factors down to 2x minus 5 and x minus 2. Set each of these individually equal to 0. So 2x minus 5 equals 0, and x minus 2 equals 0. Just solve each one individually, add the 5 over, divide by 2, and then here, add the 2 over, we get 2. So our answer can't be a 2 and 5/2. So again, our domain is going to be starting at negative infinity, all the way to the first number that causes a problem, which is going to be 2. Then union 2 up to the next one, which is 5/2. Union again, and then 5/2 onward to infinity. And this is the domain of this function in interval notation. Last, we have the rational function r of x equals 4x over 4x squared plus 1. So again, we don't care about the top, just the bottom. So 4x squared plus 1 equals 0. And we're going to solve for x. So subtract 1 over, 4x squared equals negative 1. Divide by 4, x squared equals negative 1/4. And then square root both sides. X equals plus or minus, don't need that because it actually becomes 1/2 I. And since we're dealing with complex answers here, this means there's no real answers to remove. This is the only thing it can't be. So our domain here, since there's no real restrictions, only complex, is negative infinity to positive infinity. All real numbers. So there is no restrictions for this rational function in the domain.